Today what we're going to do is we're going to look at actually putting some graphs on paper. So we're going to look at some functions and then remembering those basic graphs of functions, use that information plus a little information about evaluating a function, remember that just means plugging in the number and doing the math, to be able to graph these. Now, the first thing I want to remind you of is that mathematics, one of the things you'll notice is that mathematics behaves in very predictable ways. So you're going to see a lot of pattern in mathematics. And if you can train yourself to see some of that pattern, then it enhances your way of thinking, and that way you're thinking mathematically, which is what we want you to do. We're not really trying to make little mathematicians out of you, but we'd like for you to start recognizing patterns to make your life easier and to make you be able to think at a higher level, right? So first of all, let me just let you think about this. Let's say that you have $200, right? And you can either add or subtract to that amount, right? If you add $10, that's going to increase the amount of money you have, right? By that $10. If you spend $10, then it's going to decrease that amount. Okay? So think about patterns that you already know when you think about mathematics, because this is going to make your life a lot easier when you start working on actual problems in mathematics. So keep that in mind, that adding money increases, subtracting money decreases, and the way things increase or decrease is what we're going to be interested in when we're talking about graphing. Okay? Another thing is, remember that when you have a function, right, some f of x equals x plus 2, for example, remember that if they want you to find a value for a specific number, that simply means replace the x with that number and then do the math. So f of 2 in this case would be 2 plus 2 or 4. Okay? So just a little reminder of something that we've done in the past that will make sense to you as we work through the problems we're going to do now. Okay? So what I want to do is go to your actual homework and look at some values and some changes. So here we see the first problem in our homework, and they give you a function, and then they ask you to tell them what the function is, what the other parts of the function are going to do. Remember, the graph of y equals x squared is just a simple parabola, right? Opening up because your x squared is positive. Now it wouldn't look exactly like that, but if you think of some of the things that it does, it always opens up, and if it's just plain old x squared, that means that that curvature, that part where it changes from stops going down and starts going up, remember we looked at increasing and decreasing last time, is always going to be at the origin, right at 0, 0, right? So that's its turning point. Well, by putting in other numbers, for example here we're subtracting 4, we're going to start moving it or shifting it, okay? And there are two kinds of shift. You're going to either get shifting up or shifting down, okay? And then later we're going to talk about what happens and how things move things from side to side. But the first ones we're going to look at is shifting up and down, okay? So the way that works is if a number is added or subtracted from your x squared. So see here, this one in particular says x squared minus 4. Okay? If it's added, then what's going to happen is you're going to go up that number of units. The whole graph is just going to shift up and down. And you're going to see that my math lab is your friend when you're graphing, because it makes graphing very easy. If it's a negative, instead of going up, you'll go down, however many number of places that number gives you. So in this particular instance, since we're talking about x squared minus 4, let's go to our, then it shifts the graph of the plane graph, the parent graph of y equals x squared down by that number of units. So in this case, 4 units. So typing in your 4, check your answer, and there you go. Okay? So they're just trying to get you familiar to how different numbers will shift or move a graph. Okay? So let's continue to the next one. Let's see what they do. So here we have f of x equals x squared, so we know that's a parabola opening up. And there's something added to your x squared, so that's going to shift the graph. And this time, since we're adding 10, that's a positive 10, it's going to go up by that many units, so up 10 units. And that's all there is to it. Okay? Now, we can also have other ways and other things happening to our x squared. And one of the things we can have is we can have a parentheses raised to the second power. And what that's going to do is it's going to move it in different directions. We're not talking about just adding something to an x squared here. If you look at this one, this is not f of x equals x squared plus 6, right? That's not what's happening here. If you look at it, this says that f of x equals x plus 6, the whole thing squared. And so that's going to provide a different kind of shift. Okay? Now I'm going to show you something that's really important, and it's going to be different from the way they show you if you do the help me solve this, but it's going to lead to something later. What we want to do is, if we have one of these parentheses like this, is we want to get that 6 away from the x. And one of the easiest ways to think of that is to pretend to make an equation out of it. And that equation would always equal 0. Now to get the x completely by itself, remember we would simply do the opposite. Do you remember doing these in the earlier chapter? Okay, so we end up with x equals negative 6. So in other words, taking the 6 away from the x has the same effect as simply changing its sign. And that is a constant in mathematics. If you pull that number away from its letter, what it's going to do is it's going to change its sign. You're going to see that in several chapters that we do, in lots of different ways we use it. But it looks as if we're simply setting it equal to 0 and solving it. Okay? So this negative 6 is what's happening and is the way we're going to end up shifting our graph. Okay? So we're going to look at how that negative 6 shifts the graph. So think about, if it was just adding 6 to an x squared, that would mean a positive, so that would mean up. So let's look at our choices here, because again they give us multiple choice. We know that this isn't just adding 6 because it's in parentheses. We're squaring that whole thing. So we need to take the 6 away from the x, which gives us negative 6. And since it's not just adding 6, we know it can't be up or down. That's just adding, right? So that means that when it's like this in parentheses, it's either going to shift to the left or to the right. And as you can imagine, since if it's a negative, it's going to shift to the left, that many units. If it's a positive, it's going to shift to the right. Now, there's nothing else for it, but you're just going to have to memorize what each one of those things does. Okay? Remember, that's when you have x plus some number raised to the second power. That's what happens here. It's either going to move to the right or the left. But also remember, though, if it's x plus, so this was x plus 6 quantity squared, that's the same as x plus 6 equals 0. Solve it for the x, gives us negative 6. So this 6 looked positive when it's inside the parentheses, but when we pull it away from its x, it becomes a negative. So we're not going to be shifting to the right. we're going to be shifting to the left. Let's see how that works and make sure I get it right. So to the left, check our answer, and there you go. Okay, so you have to pay close attention to the form that you were originally given in your problem to be able to know which direction to move. Okay, so here we go. We have a function, and it's x minus 7 quantity squared. So in other words, it's a parentheses squared. So let's take that 7 away from its x. So to do that would add 7. So it's going to give us positive 7. Okay, so let me again show you that just so that you can start thinking about what happens. You're going to move that 7 away from its x. Right? So that's a positive 7. Now again, since we started off with the parentheses, we're not going to be shifting up or down. We're going to be shifting either to the right or to the left. And since the 7 is positive, it's going to shift to the right. Right? Because that's where the positive x's are. Okay? All right. Now, here's a question where they ask you to do both. Okay? So it's going to shift. So it's x plus 7, so that's going to be a negative 7. And then it's down 9 or minus 9. So pay attention to which one's going to happen. So this plus 7 is going to become negative 7. So that's mean it's going to go to the left 7 units. And then subtracting 9 means that the whole thing is going to go down 9 units. Okay? So it's just a matter of remembering which one has which effect. Okay? And they're pretty, and like I told you, my math lab is pretty helpful here because it's giving you these as multiple choice, and it's already telling you what it's doing. Now, that's good, but later they won't do that. So make sure you're understanding which one it's going to be. So it's x minus 10, so that's going to be a positive 10, so that means it's going to go to the right 10 units. It's add 6, so that means it's going to go up 6 units. Okay? Good. Now, in here they're going to give you a whole bunch of them, and one thing that we haven't talked about is this one. They haven't given you the multiplication, in other words, a coefficient in front of your x squared. So let's talk about that one really quickly before we move on. So what's going to happen is that when you have a number in front of the x squared, it's not going to move it up or down or left or right. What's going to happen is it's going to make the graph either skinnier or wider, depending on the number that you have there. So let's look at the names that they're giving things here. Okay? First of all, they're talking about the ones that we've done so far, and those are called translations. Translation means it went up or down, right? Adding or subtracting a number from your x squared, or it went either right or left, which means you started off with that parentheses, and so you have moved it either right or left depending on the sign when you got the number away from its x. The one we haven't talked about is this B, a vertical stretching. So what we need to do is we need to talk about what happens when you stretch a graph. Okay? Stretching means that you're going to pull it out wider, right? Okay? And this one is a vertical stretching, which means as you pull something longer and taller, think about those old toys like the, you probably didn't have Gumby, you're too young, but when you stretch it out, it gets thinner and thinner and thinner, kind of like a rubber band. Think of a rubber band when you pull it. I know you've seen one of those. So it's going to stretch by a certain factor. And the key here is that word of factor. Factor literally means something that's multiplied. So the only one up here that has a factor of 4 is C, right? So think about that. And don't worry that much about what the graph is going to look like at this point. Just know that it's going to stretch it vertically. And when you see that factor of 4, and that'll be your clue now. We're going to talk a little bit about why and what it does to the actual graph in a bit, and then we'll also have to look at what happens when that number is negative and what happens when that number is a fraction, because that's going to change things as well. So let's just look at each one of these and see if we can pick out the correct choices. So if you have x minus 4 squared, that's a parentheses. So pull the 4 away from the x, which makes it positive, which means that it's going to go to the right. So 4 units to the right is D. So there we go. Here's x squared minus 4, so we're doing a subtracting 4, so that means it's going to go down 4 units. So that's a translation, 4 units down. So that's C, is our choice there. 4x squared means a factor of 4. It's a vertical stretching by a factor of 4, which is B in this case. X plus 4 squared means it's x plus 4 in parentheses squared, means take the 4 away from the x, which gives you negative 4. So that means negative 4 is a translation, 4 units to the left. And that's A in our case here. And finally, x plus squared plus 4 just means you're adding 4 to it. That means you're going 4 units up, which is E. Okay? They're going to use every one of these. It's another beautiful thing about my math lab. Check it, and we got it right. Okay? So the only one is that vertical stretching by a factor of 4. And again, don't panic if you don't know what that means right now. Just use factor of 4 to know which one to choose. Okay? Let's go to the next question. Okay? Now what we're going to do is we're going to match each equation with the sketch of its graph. Okay? And if you think about the parent graph and then what you're doing to it, you can easily pick which one you need to choose. Okay? So, you click on the icon, helicopter tour. Click on the icon to choose the correct graph because you're going to just have letter choices here. So, the first one we're given, click on the icon to get the choices here. It's the basic graph of a parabola. The x squared is positive, which means it's opening up. Remember, that's important because look at your choices. There's some that open down. And it's x squared plus 2, which means what happened is the basic graph has simply gone up 2 units. And if you remember, the basic graph always hits at 0, 0. So what happens is now, instead of starting at 0, 0, or having that turning point at 0, 0, it's gone up 2 units. So look over here, and let's see which one. So that one has obviously been shifted down, right? This one is shifted up, so that's a possibility. This one is to the right. This one has been flipped over, and we'll talk about what that word is in a minute. This one has been moved over and up. This looks long and skinny, right? This one is to the left and down. This one's to the right and up. So do you see that you get lots of choices? But we're looking for the one that looks like it's just been moved up to. So to me, that looks like B. Let's check it out to make sure. There we go. And they're just going to give you a bunch of these to choose. Here, this one's x squared minus 2, so that means they pulled it down 2. So that looks like A to me. Right? So these are going to be fairly obvious. You just need to pick the correct one. So what you're doing here is you're practicing looking at what the graph looks like when you do a certain thing to it, but also remembering, okay, what does this one mean? Does that mean I'm going up, then I'm going down, I'm going right or left? Okay? So let's just go ahead and click through the rest of these. X plus 2 squared, so that means that, get that way, it's negative 2, so that means to the left 2. So it's still staying on that line, so we didn't go up or down any, we just went to the left 2, so that looks like G to me. Okay, there you go. The correct graph for y equals x plus 2 squared, so this time we're going to the right 2. Okay. So that looks like C. Okay. You can make these bigger if you want to look at the actual numbers, but they're pretty predictable. Okay, the correct graph for y equals 2x squared is, now, that means that we haven't moved it up or down or right or left. But what we've done is we've stretched it out, made it narrower than the original graph, right? Now, it can't be that because that one's upside down. This one's been down, this one's up, this one's to the right. So here's the one that's still at 0, 0. So this is the same graph. And what's happened is, if you look at the parent graph, it would be wider. We've stretched it out. So that's a vertical stretching. And don't worry about by how much. You're never going to be asked that by a factor of 2. The correct graph for negative 5x squared, okay, that means it's still the right graph, but look at that, it's negative this time. So that means it doesn't open up, it opens down. So just because of that negative, we already know that it's got to be D, right? That's a vertical stretching, but it's also flipping it over the axis. So turning it upside down. Here's one where we've done two things. So that means 2 to the right, and then up 5, right? We just did those others that were like that. So 2 to the right, and then up 5. That looks like 2 to the left and up 5. So 2 to the right and up 5. Looks like H to me. Then we're never going to use the same one twice either. So here it's plus 2, so that's 2 to the left, even though it says plus. Remember, when you take it away from that x, it turns it into a negative. So left 2 and up 5, so that's E. And finally, to the left 2 and down 5. So finding that. I'm terrible at finding things. So that means to the left 2 and down 5, so that's I. Okay, so you're just going to be practicing making a visual representation of what it means to translate or stretch things. Okay, here we go. Here's another one that's just exactly the same, but this time the graph is an absolute value. Doesn't change anything. Just remember that the graphs of absolute values aren't parabolas, those U-shapes, they're a V-shape. But it does exactly the same thing. So if it's the absolute value of x minus 4, now this is not in parentheses squared, so that means that it's 4 down from where it would be at the origin. So 4 down, that looks like C to me, so just check that out. Whoops. Maybe it's not C. Let me see. So x minus 4, hold on. I promise I'm going to go back and redo all these videos for next year so that when I make a mistake, the next year's students won't know it. What I want you to remember is that, look at where the 4 is, the x minus 4. Do you see it's inside there with it? That's the equivalent of having it in parentheses and squared, but obviously it's not, but it's inside there. So that means that you're going to take that away from it. So that means it gives you positive 4 is the move. And since it's in there with the x, that means that you're going to go to the right 4. Now, look at this one. We have the absolute value of x, and we're subtracting 4. So that means down 4. That's the one I clicked on. Sorry about that. So you'll see the difference. So make sure you remember, if it's in there with the inside the absolute value bars, then it behaves the same way as the parentheses problems that we did earlier. Okay? But other than that, it's just going to move or get skinnier, etc. All right. So let's see what they do to us next. Yeah, we're going to go ahead and go. You don't need to see me work through every single one of those, and besides, you need to practice. All right, now we're actually going to start graphing some functions. And if you remember the parent graphs of the functions, then you're already going to know what shapes that they should make. And here's where graphing using my math lab becomes your absolute friend. Okay? So, let's look first at our function. The function that we're graphing is f of x equals 5 times the absolute value of x. So remember, those upright bars means absolute values. So what we're looking for is a graph that makes a perfect V shape. Well, if it's a perfect V shape, all I really need to know is, where is it here? And I just need one point on one side so that I know what it's doing somewhere. And the reason for that is because you're going to have to click on the right shape and just find out where it's going in order to graph using my MATLAB. It won't let you pick into a bunch of different points. So what we're going to do is we're going to go back to that chart that we kind of looked at before. But what we're going to do is we're going to find the parent graph and understand where it is, and then all we really need is one other value. So let me show you what that looks like when we click to enlarge the graph. You'll see the graphing tools that are available to us. Hold on just one second. And you're going to like it. Trust me. All right? So first thing, we know that the function is an absolute value function, so we have to first find the correct parent graph. And if you look right here, you have a V-shape. So just click on the V-shape. Okay? And we're going to click on the graph to plot what's called the vertex. The vertex simply means that little point where the V stops, where it stops going down and starts going up. It's called the same thing with the parabola, with that U shape. That point at change is called the vertex. So we need to plot the vertex. Well, if you look at this one, we're not adding or subtracting anything to our x, right? We've got a factor of 5, so that means we're stretching it, so we're making it long and narrow. So that means that the vertex is going to be at the origin, at 0, 0, just like any other plain old, just as if you had the f of x equals the absolute value of x. Now, but what we have to do is we have to choose one more value so that we can find out what's it doing somewhere else. And then we can click on that point, and my MATLAB will automatically do the graphing for us. So let's choose any number we want to for x, and then find out what that would make our y value so we can plot it. And again, it doesn't matter what number you choose. My only advice is that if you have a fraction, you choose whatever number is on the bottom, because what that'll do is it'll eliminate the fraction for you. Okay? But in this case, we just have 5 times the absolute value of x. So I'm just going to pick 5 just because I can. No, I can't. It's too big for this one. Let's choose a smaller number. You don't want to pick 0 because you're already on 0. So we want to pick some other number. Let's just pick, I don't know, 3. And the reason I don't want to pick 1 most of the time is because it makes the graph really, really tiny and hard to see. But you can always make this thing bigger if you want to. We're going to just use 3 just for fun. So, y'all are thinking algebra's fun. Not going to happen, but oh well. So, all we're going to do is replace that x with 3. Now let's do the math. So that's 5 times the absolute value of 3. Absolute value of 3 is 3, right? So 5 times 3 is 15. So if x is 3, then f of x, or y, is 15. So what I need to do is find the point on the graph where, you see it automatically gives you your V shape because we clicked on that in the first place. So we're going to find the point where x is 3, right? So that means go to the right 3 places, and then we go up 15 places. And if you look right here, you know you're on the right spot because it'll tell you you're in the right numbers, right in the right values. So make sure that you're really careful about that. And all you want to do is just click on it. When you're on the right spot, make sure you're on the right spot, right? And that selects it. And you know it's been selected because it'll turn from blue to that orangey gold color. Okay? Now we say, and you see that it already graphed the other side for us, right? So we're just going to save that so that we can check our answer. And there you go. So all you need to do is know where that V is going to be, the vertex is going to be, and then find one other value to be able to graph it. And you can do that for any of these. All right? You only need one other value once you know where that vertex is going to be. Okay? And because we didn't have anything added or subtracted or anything, we knew the vertex was just going to be at 0, 0. So they're going to give us several to be able to look at. But we're almost done with this. prompting questions. So let's look at our next graph. Here we have another absolute value, 2/3 times the absolute value of x. We don't have anything added or subtracted from it, so that means we know that that vertex is going to be at 0, 0, right there in the center. Okay. What we don't know is what's going to happen other than that. So we know it's absolute value, so it's got to be that V shape. There's nothing added or subtracted, so that means that the origin is going to be the middle, going to be the vertex. See, it automatically gives us our V shape. Now we need to know where that V is going by simply choosing another point. Okay, so let's look at it. All we have to do is choose any other value of x and then find f of x. Now notice this time it's a fraction. And so anytime you have a fraction, the best number to choose to plug in is that denominator, the bottom number. Okay? You could use any number, right? But if you look on here, you're not going to find a lot of fractions up there. You're going to find whole numbers. So what we want to do is we want to choose some number that will eliminate the fraction, right? And since you're multiplying this times x, and the fraction bar means to divide, the opposite of multiply is divide, whatever you're dividing by, you multiply. So we're going to use 3. If you push 2/3 times x, the absolute value of x, so 2/3 times the absolute value, of 3. The absolute value of 3 is 3, right? So that means 2/3 times 3. So what's going to happen is those are going to eliminate that. Or if you multiply it straight across, you get 6/3, which is 2. So and of course, use that calculator. If you don't know how to do fractions, just push 2/3 times 3 in your calculator. This is not the time to learn all of that arithmetic if you don't already know it. So here we go. We're going to look at plotting that point. So we chose x is 3, so it means go over 3, right? Which gave us a 2 for our function value. So there it is. We're at the point 3, 2. You see up there in the upper right, in the yellow, they tell you where you are. Click at that point, that will set the graph. If you don't click on it, it's not going to set it, so it won't work. Okay? So that gives us our graph. Check the answer, and there we are. I guarantee you it's a million times easier than what they do. You do not need 5 different points in order to do this, because my math lab is only going to let you click on 2, right? The vertex and the point, and one other point. Okay? Move forward. -1/3 times x squared. Now there are two things happening here, or a couple things happening here. First of all, this is not absolute value. This is a parabola, right? Now, so we're going to get this U-shaped, right? Okay. We don't have anything added or subtracted, so we know that our vertex is going to be at 0, 0. Now look what happened when I just clicked on there, though. It gave me the parabola already, and then it gave me this little business down here about shrinking and shifting. And if you look at the bottom, it also tells you about reflections. A reflection means you've changed the sign, so you don't get it opening up, you get it opening down. So if you look at this function, this first thing about the function is, it says f of x is a negative, right? Well, if it's negative, that means it has that it's going to be reflected, right? And since it's a function in x, it's the x that's being reflected. In other words, instead of opening up like we have it right now, we need it to open down, okay? So the first thing we'll do is click on that to get it to open in the right direction. So you just see, all I did was click on the x reflection to get it to open downward. Now, we know there wasn't anything added or subtracted, so the vertex is not going to move. What we want to do is choose any number you want to see how it's going to move. But if you look, it's got vertical stretches or shrinking. So what we're going to do is we're just going to see, is this going to stretch or shrink? And is it vertical? Are you stretching it up a lot further, or are you stretching it out horizontally? Okay? And so I'm going to go back and do a similar question because I clicked on the answer already. So let's go back and look at it. Here we go. So here's our function. We know it's negative, right? And it's an x squared, so that tells us two things about the graph. X squared tells us it's a parabola, or an x squared tool, if you even look at it. And we know that it's negative, which means that, and just click anywhere on the graph to get the parabola to start, that it's an x reflection, so it's going to be opening down. And remember, if you have a factor or a number, a multiplier in front of that number, then it's going to be a vertical stretch or shrink, depending on what kind of number you're going to get. If it's a fraction or a whole number, it doesn't matter to you right now. All you want to know is what it's doing. It's a vertical stretch or shrink. Vertical, right? Horizontal means you're doing it with y's. There's your clue for that. So just click on your vertical stretch. It's not a shift. We're not going up or down. That would be adding or subtracting. When you're multiplying, it's a stretch or shrink, right? So just clear that out. But look at our, it's a fraction. So it's going to be 1 over 11 is our stretch or shrink, right? Whatever that number is in front of your x squared is the stretch or the shrink, right? And if you click on save, then it automatically, and see in this case, it shrunk it vertically. In other words, it made it wider instead of narrower. Then that's because this was a fraction. A fraction is always going to be a shrink. A whole number is always going to be a stretch. Okay? So we save our answer. It automatically graphs it, turns it blue. Check it. There you go. Right? So if you're given that little shrink or stretch, all they want you to do is put that number in front. Make sure you know what kind of graph it is, and if it's if it's going to be a reflection, make sure if you know what sign that is. So let's look at another one of those. This one, graph the following function. So it's x squared minus 8. So we already know that means a parabola, right? So just go over here and see that it gives me a lot of choices. This one's not going to go through 0, 0 because I'm subtracting that 8. So that, and since it's x squared minus 8, that means down 8 units. So the vertex of this parabola actually happens down here. But watch what happens when I click there. It just gives me the parent graph, right? And then it asks me to see if this is what kind of shift I get. So think about this one is x minus 8, so that means this point where it changes is going to go down 8 because it's not in parentheses, it's just minus 8. So if it's down 8, that is a vertical shift, right? We shifted down, so up and down is vertical, so we went down 8. Okay, so let's just get rid of that 0, and it's a vertical shift down 8. Okay, let's save it. Do you see it? Dropped our graph down to where the negative 8 is. And there you are. Okay, so my math lab is really graphing friendly. You'll love it. If you've never graphed before, boy, this is the time to learn, or the time it's going to happen for you. Now look at this one. This one is x minus 8 squared. So it's still an x and it's squared. So that means that the graph of it is going to be a parabola. So click anywhere on the graph to get the parabola there. And it's x minus 8 squared, so that 8 is inside the parentheses. Take it away from the x, it's going to give you a plus 8. So that means it's going to move to the right 8. Now, right or left or horizontal, right? So we're going to get a shift horizontally 8 units. Put that in there. So shifted it over 8 units to the right. There you go. So don't make it hard on yourself. Try to be careful when you're doing these. Now, if you look at this one, it gives you a lot of things going on here. All right? And so since we have so much going on with it, we're going to get vertical, we're going to get horizontal, we're going to get shrinking. Then it's not going to let you just click wherever you want to when you want these. So make sure you're being very careful. You have more than one thing going on here. First thing is, we know that we're going to get from the x minus 3 squared, take that away, it's going to give us a positive 3. That's a horizontal shift, right? 3 units, okay? It also subtracts 3. That's a vertical shift down 3 units. So -3, make sure you put that minus to make sure to tell it to go down or up. And then we get a multiplier of 3, right? So that multiplier of 3 is a vertical stretch of 3. Okay? Now, this just happened that they used all 3's. That doesn't mean they're always going to be the same number, right? So there's our graph. Well, let's see if I did it right. There we go. So just do each one independently, one thing at a time. Okay? All right. And there we go. Our homework is done. So way easier if you think about those shifts and reflections, etc., instead of having to just plug in bunches of numbers. All right? Got one more section to go with this chapter, and it is ugly looking, but really, really, really easy as long as you can add, subtract, multiply, and divide, or use your calculator to do it. Okay? Thanks. Bye, guys.